Good day, everyone. Welcome to another edition of our mathematics presentation. Okay, the topic that we are going to discuss today, Mathematics 6, Quarter 1, Module 7. Okay, the topic that we are going to discuss today, Mathematics 6, Quarter 1, Module 7. Terminating, non-terminating, and repeating quotient. Now let's take on terminating quotients. Now, what do you mean by terminating quotients? These are quotients from division that has an ending part. Meaning to say, during the division process, we will be able to terminate the division. Meaning to say, there will be no remainder in the process of division. That's why we call them terminating quotient. Meaning, it has an ending part. It will end with no remainder at all. Okay, let's take into example number 1. And we will try to determine whether this division process will end up into a terminating quotient. What do you mean by terminating quotient again? It will end up with no remainder at all. It will be having an ending part. Okay, so we can apply the rule of divisibility in this particular example. And we don't need to do the actual division to learn or to know whether these numbers can end up into a terminating quotient. We can simply apply the rule of divisibility. So, the divisor is 3. So, we will look into the rule of divisibility of number 3. So, we will recall the rule. And we have that in your grade 5 lesson about the divisibility of numbers. And I have also uploaded a video about that one for grade 5 about the divisibility of numbers. So, we will apply. What does the rule says? If the sum of all the digits is divisible by 3, then the rest of the numbers is also divisible by 3. So, we will add. 2 plus 3, we have 5, plus 4, we have 9. 9 is divisible by 3. So, we can simply say, and we can simply answer the number 1 question that this example is a terminating quotient even if we did not perform the actual division, because we apply only the rule of divisibility. No need of doing the actual division, because this is just simple numbers, smaller numbers divided by 3. So we can determine and we can answer right away in the exercises in your module that this particular division operation has a terminating quotient. Okay, let's take another example of another terminating quotient. So we have 456 divided by 6. Okay, let's do it in the rule of divisibility. So we have 456 divided by 6. What the rule says in the rule of divisibility of number 6? A number is divisible by 6 if the number is divisible by 2 and divisible by 3. So we will have, if it is divisible by 2, it is an even number in the last digit, so it is divisible by 2. How about 3? So we will add all the digits. 4 plus 5, we have 9, plus 6, we have 15. 15 is divisible by 3. Therefore, the rule says, if the number is divisible by 2 and divisible by 3, it is also divisible by 6. So, without doing the actual division, we can say that 456 is divisible by 6. Therefore, this is a terminating quotient. So, in your exercises, in your module, even if you will not perform the actual division, you will just simply apply the rule of divisibility. You can answer right away. You don't need to do the actual division because you are not asked to do the actual division. You are only asked whether this division process is a terminating quotient, not terminating quotient, or a repeating quotient? That is the question. If you are asked to divide, then you will do the division. But that particular example, that particular exercises in your module does not ask you to do the actual division. You are only asked to answer whether this is a terminating quotient or a not terminating quotient. So we apply the rule of divisibility because you are not asked to solve. You are not asked to do the actual division. But if you will be asked to do the actual division, then you will have to solve using the steps in dividing numbers. Okay, let's now do it in the actual division. So we will divide 456 divided by 6 so that we can prove also that this is a terminating quotient. So we will divide. So our first digit quotient is 7. So 7 times 6, we have 42. So we will subtract 45 minus 42, we have 3. So we will bring down 6. So our next dividend is 36. We will divide it by 6. So we have our second digit quotient is 6. 6 times 6, we have 36. So 36 minus 36, we have 0. So we were able to come up with an ending part. We were able to end up the division process. Therefore, we were able to prove that this division process is a terminating quotient because there is an ending part. We end up with no remainder at all. Okay, let's discuss about non-terminating and repeating quotient. So what is this non-terminating? Okay, these are quotient having no ending part, meaning it will continuously be having a remainder. So no matter how long you gone into the division process, it will not come up with an ending part. It is a never-ending division. So this is what we call non-terminating. And what is this repeating quotient? These are quotient having repeated digits. Meaning to say, if you perform the division, it will repeatedly be having the same digits. So if the digits will be 3, it will be a continuous number 3 up to the end of the division. But you will not be able to end the division. It will be a continuous 3, 3, 3 and no ending at all. So if it is a 6, then it is a continuous number 6, meaning a repeated decimal. The number will be repeated and repeated all the way, and there will be no ending part. So that is what we call repeated quotient. So we will have some examples about a repeated quotient and non-terminating quotient. Okay, let's have an example of a non-terminating and repeated quotient. You have 833 divided by 3. So we will have to do the actual division to know whether this division will end up into a non-terminating quotient or a repeated quotient. Okay, let's perform the actual division now. We have 833 divided by 3. So first digit dividend, we have 8. 8 divided by 3, so we will only have 2. 2 times 3, we have 6. So 8 minus 6, we have 2. So we bring down 3. So 23 is the next digit quotient. So 23 divided by 3, so we will only have 7. 7 times 3, we have 21. So 23 minus 21, we have a remainder of 2. So we will bring down 3. So 23 will now be the next dividend. 23 divided by 3, we will only have 7. 7 times 3, we have 21. We have a remainder of 2. So we have no more digits left in our dividend, but still we have our remainder. So to continue the division, we will have the decimal digits. We add 0. So before adding 0, we place the decimal point. In line with our dividend also, we will also place decimal point in our quotient to signify that we are now on the decimal digits. So since we bring down 0, 2 becomes 20. 20 divided by 3, we will only have 6. 6 times 3, we have 18. So we have 20 minus 18, we have 2. Another remainder. So again, we will add another 0 to continue the division because we still have the remainder. So again, 20 divided by 3, we have 6. 6 times 3, we have 18. Again, we will subtract 18 from 20, we have a remainder of 2. So we will again add another 0 to continue the division because we still have the remainder. So 20 divided by 3, we'll have 6. So 6 times 3, we have 18. 20 minus 18 equals 2. There is a never-ending remainder 2. So we will never end the remainder. So we will also never end our quotient, which is 6. There is a continuous 6 in our quotient. So there is a repeated quotient, the repeated digit, which is 6. So if we will continue, it will never end. It will still be 6 in our quotient. That's why we call this non-terminating. We can never terminate the division because there is a continuous remainder. Since the digits are being repeated, we call this a repeating quotient. So this is how non-terminating and repeating quotient is being related. Okay, let's have another example of a non-terminating and repeating quotient. So we have 754 divided by 3. So let's try to find out whether this division process will be a non-terminating and a repeating quotient. Okay, let's do the actual division now to determine whether this division process is a non-terminating or repeating quotient. So we have 754 divided by 3. So we have the first digit of our dividend. We have 7. So 7 divided by 3. So we'll only have 2. 2 times 3, we have 6. So 7 minus 6, we have 1. Then we will bring down 5. Next digit quotient, we have 5 because 5 multiplied by 3 will give us 15. So 15 minus 15 will have 0. So we will bring down 4. Okay. 4 divided by 3 will only have 1. 1 times 3 we have 3. So we will subtract 3 from 4. So we only have 1. So remember remainder 1. So there is no more digit left in our dividend, but we have still the remainder. So we need to place another 0. So for placing 0, we place the decimal point. So to continue the division, in our dividend, we will also align the decimal point in our dividend. So after 1, we will have decimal point. Then we will continue the division because our dividend becomes now 10 because we bring down 0. So 10 divided by 3, we will only have 3. So 3 times 3, we have 9. So 10 minus 9, we'll have again remainder 1. So again, we will add another 0 to continue the division because we still have remainder of 1. So we have 10 divided by 3. We'll also have the same answer, which is 9. 10 minus 9 will have a remainder of 1. So again, we will add another 0 and the dividend becomes 10. So we have 10 divided by 3. We will only have 3. 3 times 3 we have 9. So 10 minus 9 will always have a remainder of 1. So there will be a continuous remainder 1. And in our quotient, we will also have a continuous quotient of 3. So there will be no ending part in our division. So if we will continue dividing, we will have a repeated quotient, which is 3. And this is what we call a non-terminating quotient. Why non-terminating? Because we will never have an ending part. It will always be a continuous remainder of 1 and a continuous quotient of 3. Therefore, it is a non-terminating. At the same time, it is a repeating quotient because digits 3 will always be repeated all the way down. No ending part. So this is the relationship between non-terminating and repeating quotient.